Okay, so hello everyone, and thank you for affording me the opportunity to present my mission idea. My name is Dirk Slabber, and I will be presenting the use of the IoT constellation for Antarctic sea ice monitoring to better predict the effects of climate change. So in the interest of time, I will keep this presentation short. I'll quickly dive into the explanation of what sea ice is and why it's important, as well as why we have a need for on-the-ground sensors. Thereafter, I will quickly present an overview of the technical considerations of the mission and how I envision South Africa and others can support this mission. So Antarctica is a landmass that's completely covered in permanent ice. Around it, however, is the sea ice zone, characterized by ice floating on the ocean surface. Critically, the consistency and size of this zone is seasonal, and large parts of it ranges from either a solid or going all the way to a slush. So as this area consists of about 10% of the oceanic surface of the world, it is critical in maintaining global weather patterns. It acts as a massive heat sink, reflects large amounts of solar radiation, and critically, it also protects our Antarctic ice shelves from the constant beating of waves. Now, in contrast to the North Pole, and giving much fuel to climate change naysayers, the Antarctic sea ice zone has actually been growing the last couple of decades. However, this growth pattern stopped in 2016, and after that, we've seen a yearly record-breaking decline in the growth of the sea ice. So this rapid change promises the disappearance of the sea ice altogether within the next few decades, as well as pollutes massive environmental impacts. So even though this zone has massive effects on the global weather, it remains extremely unmonitored, hampering our ability to model and predict well into the future. While Earth observation satellites do provide measurements of the Antarctic, their data calibration, as well as global weather models, rely on up-to-date ground data. And compared to other regions of on-the-ground sampling in the Antarctic is extremely sporadic and only localized to the Antarctic exhibitions happening mainly during the summer months. So thus, there's still a lot of uncertainty regarding factors such as ice consistency, thickness, and of course, the dynamic ice, sea, air, thermal interactions. And these uncertainties add to the large error margins when we create long-term climate predictions and then stalls governments from making timely and informed decisions. So the need exists then for us to capture this data in an effort to both advocate for the fight against climate change, as well as to predict and prepare for climate change or climate-related disasters. So my proposal is then to implement a network of IoT sensor buoys across the sea ice zone. These can be heavily dispersed, where we only need one or less than one every 1,000 square kilometers, and data sampling does not have to occur more than once a day. These buoys will then carry a suite of appropriate sensors to supplement Earth observation with year-round consistent environmental sampling. This last point has been a stumbling block for previous research groups implementing similar experiments using specifically iridium satellites. However, by using communication protocols such as LoRa or using a mesh network technologies, I believe our buoys can be quite resilient to the power requirements placed on any system during the Antarctic winter. So while it's not unnegotiable for this mission, I also would like to propose that we consider raising the constellation inclination to polar. This change will, of course, be expensive, and the equatorial regions will see less coverage. However, it may be beneficial or worth it as our constellation will then cover these very important upcoming geopolitical and scientific regions. So as for the buoys themselves, there are many design challenges. Of course, low temperatures, moistures, and reduced sunlight they are included in these. In addition, while I have a number of sensors listed here, actual input from scientists in global weather data and Antarctic research is required. Luckily, though, UNISEC consists of quite a few member states with very active Antarctic research programs, such as South Africa, New Zealand, and Argentina. And in this regard, this mission is a great opportunity not only international collaboration between these countries, but also between the space and Antarctic research sections or sectors within these countries. Coincidentally, I also believe these three countries could hold the ground stations to intercept the IoT data and thus free the satellites almost immediately after they passed over the Antarctic. So in my final slide, I wish to highlight the feasibility of this mission given the South African context and how we can contribute to the constellation. We are fortunate in having universities with experience in satellite development, a bustling private sector, and government institutions that are open to satellite mission proposals. And I remain optimistic that we can coordinate the various local stakeholders and get them to support and fund this IoT program. Lastly, though, I would also like to use this opportunity to invite other UNISEC members, as well as, or especially, our African neighbors, to collaborate with South Africa in building this constellation. We are eager to help build the African space sector, and this includes possible financial incentives from our private industry, academic partnerships, and of course, a greater chance of funding from our respective governments for the demonstration of high-tech Pan-African collaboration. So with that, I would like to conclude. I would like to restate my commitment and belief that this constellation is an amazing opportunity to demonstrate unity and collaboration in mankind's quest to reach the stars. Regardless of the uncertainty of the global stage, if we can work together in our own countries and as a community, the only outcome can be success for humanity. Thank you, and I would like to use the remaining time to answer any questions that you might have, or you can email it to the email address listed on the screen. Thank you.